Okay, so here we are, cleaned up, ready to go. Suppose a 200 Newton force is applied to the box for several seconds. Well, that's going to cause it to move at 8 meters per second squared for several seconds. Then the force is reduced to F equals 100 newtons. What is the strength of the frictional force after the force is reduced? All right, so now, free body diagram. Of course, we're talking about forces, so we're going to start with a free body diagram. We have mg, which is 200. We have Fn, which is opposite of 200. We have Ff. And we have Fa. Now, why did I draw it like this? How do I know we're going to the right? Because we started accelerating at 8 meters per second squared. So we obviously are starting with some kind of velocity, which if we have any kind of velocity, that means we're moving. If we're moving, we use kinetic friction. So our frictional force is only the 40 newtons. It's not the 160 newtons. Don't think that instantly you're going to stop. That static frictional force will come about once this box comes to rest. Okay? So let's see. What is the frictional force? Frictional force is going to be that 40 newtons. And what motion does it have? Being specific, let's find out. The stuff that makes it go, we're still above 40 newtons for that applied force. So that applied force minus the stuff that holds it back, Ff, equals mass times acceleration. So Fa, in this instance, is 100 minus 40. So we have 60 equals 20A. 60 divided by 20, A equals 3 meters per second squared. So we found out that the acceleration, sorry, I cleaned everything up, is 3 meters per second squared, right? So we are actually still speeding up because remember our free body diagram. We still have more force going to the right than we have to the left. Frictional force and then the applied force. So this tells us we're still speeding up. Can't leave free body diagram incomplete. That would be sloppy. All right, on to E. 200 Newton force is applied, and then the force is reduced to only 10 newtons. What is the strength of the frictional force? All right, so if it only goes to 10 newtons, just a little baby force. And then we have the easy ones, mg and Fn. Are we still moving? Yes, we are still moving. So this arrow should be about 4 times the length because remember our frictional force is 40 newtons. Right? So frictional force equals 40 newtons. All right, we have a free body diagram. We want to describe this motion specifically. So let's go ahead and do a Newton's second law equation, the stuff that makes it go minus the stuff that holds it back. This applied force is in the direction of the motion still, right? So it would be the applied force minus your frictional force equals mass times acceleration. So we're going to start with 10 minus our frictional force, which is 40, equals 20A. So we have negative 30 divided by 20 equals A. Negative 30 divided by 20 equals negative 1.5. Meters per second squared. Always including the units and give it a nice circle. So that's it for that one. That page almost. I think there's one more left on that page. We'll hit it in the next one.